Well, hello everyone. First of all, I'd like to thank the invitation to this international webinar. This presentation is about the paper tracing the history from Rodinia breakup to the Gondwana amalgamation in the Embu Terrane, southern Ribeira Belt, Brazil, with my colleagues from University of São Paulo and Mexico. This research was developed in the Institute of Geoscience of University of São Paulo, and the isotopic analysis at CPGEO, Geochronological and Isotopic Geochemical Research Center, with financial support of FAPESP, the São Paulo Research Foundation. Well, this talk is divided into this item: some general and tectonic information, some results of this research, and tectonic implications and final conclusions. Mantiqueira Province, Ribeira Belt. In the reconstruction of West Gondwana, you can see the cratons and cratonic fragments in dark gray. Rio de la Plata, Paranapanema, Luiz Alves, Riuapa, Amazônia, São Luís, West African, São Francisco, Congo, Kalahari, and the Brasiliano Pan-African belts. In red here, the Mantiqueira system or Mantiqueira province, composed by the Dom Feliciano belt to the south, the Ribeira Belt at the central part, and Araçuaí belt to the north. This province is the major tectonic unit of southern Brazil, resulting from the closure of the Admeister Ocean during Gondwana assembly, and is structurally marked by the juxtaposition of several geotectonic domains with different individual evolutions. The studied area is around here in the Ribeira Belt, among the Luiz Alves, Paranapanema, and São Francisco Craton. Well, this is a general outline of the central southern area of the Mantiqueira province, including the Ribeira Belt and Dom Feliciano Belt. The oldest domains are the Rio de la Plata Craton, south of Dom Feliciano Belt, Luiz Alves Craton, Paranapanema block beneath the Paraná Basin, and São Francisco Craton. The Ribeira Belt, composed by several tectonic terrains limited by shear zones, including Embu, Apiaí, and Curitiba, and coastal terrain, and the Dom Feliciano belt represent two low to medium grade metamorphic metavolcano-sedimentary belts and intrusive granitoids. These two belts are separated by two granite gneiss terrains. The Curitiba terrain here in purple, strongly mimetized in the Brasiliano orogenic cycle, and the Luiz Alves terrain. The southern Ribeira Belt is composed by Embu, focus of this talk, Apiaí, Curitiba, Piensuit, and coastal terrains, limited by major shear or suture zone. Well, let's talk about some available geological and geochronological data of each terrain. The Luiz Alves terrain here in light gray acted as foreland for the development of the Neoproterozoic Pan-African Brasiliano orogenic belts in the Mantiqueira province. Consists of migmatites, granite gneiss association with TTG signatures. Available geochronological data indicate an Archean to Paleoproterozoic evolution of the basement of the Luiz Alves terrain, with tectonic stabilization at the end of Paleoproterozoic. The Curitiba terrain here is a granite gneiss terrain strongly migmatized in the Brasiliano orogenic cycle, the basement in dark gray, with Riacean age 2100 million years. Igneous protolith underwent to medium high-grade metamorphism associated with extensive migmatization at 600 million years. Neoproterozoic cover in green colors is represented by sequences of low to high metamorph gray and 0.9 to 0.6 gigayears time interval for the depositional ages. The PN suite here in purple consists of a precollisional calc-alkaline arc-related granite belt with ages around 615 and mafic ultramafic suite of 630, interpreted as remains of abducted ocean floor of Adamaster Ocean. Well, the Apiaí terrain north of Cubatão Shear Zone and Santa Isabel Shear Zone was formed by the amalgamation of metavolcanosedimentary sequences including Calmian, Teutonian, passive margin deposits. Three main intervals of sedimentation are observed, represented by numbers 1, 2, and 3. Well, basementing layers here and here are composed by gneiss migmatic rocks and A-type deformed cyanogranite with Riacean and Staterian ages. In burgundy color here and here, calc-alkaline precollisional granites with ages around 620 to 590 million years. The coastal terrain is divided into two domains, the Paranaguá and Mongaguá domain, limited by at east by the Atlantic Ocean. The Cubatão Shear Zone here and Itariri Shear Zone here are the boundary separating the Mongaguá domain from the Embu and Curitiba terrains. These shear zones are the boundary separating the Paranaguá domain from the Luiz Alves Craton and Curitiba terrain. This coastal terrain is constituted by a variety of neoproterozoic granitoids and supracrustal remains here in brown. The basement rocks with Riacean ages underwent migmatization in the neoproterozoic around 600 million years. Well, practically all these terrains were intruded by these post-tectonic granite plutons, represented by the red color, of alkaline peralkaline signature around 580 million years. The Embu terrain is the focus of this study, is composed mainly by supercrustal sequence in brown affected by medium to high grade metamorphism and intrusive neoproterozoic granite since the Devonian with typically crustal signatures. The Rio Capivari complex with a very small area in this region in darker color occurred as a Paleoproterozoic basement in layers composed mainly of orthogneiss and amphibolytic rocks of around 2.2 gigayears, reworking of Archean rocks, all reworked by the Brasiliano Rodinia. The depositional age of the supracrustals of the Embu terrain is constrained to several intervals from the eastern part and western part of this terrain. Well, the studied area is highlighted here in the southern limit of this terrain. This is the Embu terrain, Curitiba and Mongaguá domain from coastal terrain, the dextral Cubatão shear zone, and sinistral Itariri shear zone. The metasedimentary rocks in brown are extremely weathered and include schists, occasionally migmatized, subordinate quartzite, and calc-silicate rocks indicating medium-high temperature and low to medium pressure metamorphism of amphibolite facies. The main foliation is normally parallel to a myelinitic foliation. The Sete Barras granite here in pink and Juquiá granite here in purple color granites intrude the metasedimentary rocks and are elongated according to the shear zones. Well, in this area, the geometric relation between the northeast dipping to southeast myelonitic foliation, the plunging of stretching lineation to southwest, and the dextral kinematic indicators are compatible with a local transtensional regime in the area of the Sete Barras granite. Well, some petrography information of the metasedimentary rocks. Here, an extremely weathered garnet biotite schist with quartz feldspar, leucosomatic bands, photomicrographs of cordierite biotite muscovite quartz schists, asymmetrical shear bands, and precious shadow of muscovite porphyroclast indicating a dextral sense of movement. Well, the Juquiá is a proto-melanite 2-mica granite. The melanitic texture are characterized by the sigmoidal K-feldspar porphyroclasts and orientation of mafic minerals. The Sete Barras is a proto-melanite tourmaline garnet 2-mica granite, shows evidence here and here of a syntectonic crystallization, and the kinematic indicators such as mica fish yield a dextral sense of shear. Some whole rock geochemistry and isotopic information. Well, the granites have a high K calc-alkaline character and slightly pyroluminous. The Juquiá type is best described as a ferron calc-alkalic 2-mica granite, while the Sete Barras is a ferron alkali-calcic 2-mica granite. The Juquiá samples have a relatively strong fascination between light and heavy hard earth elements and some negative European anomalies comparable to those found in average up continental crust. The Sete Barras samples in red display remarkable heavy hard earth elements enrichment with strong European anomaly typical of highly evolved granites. The strong negative epsilon neodymium and epsilon half nu values that I'll show later, the high initial strontium ratios, and the upper crust as the main source combined with its Paleoproterozoic TDM model ages indicate that both magmatism is characterized by crustal evolved signatures with sources of long crustal residence falling in the continental crust enriched field. The strontium evolution diagram indicates not only different sources but also distinct evolution for these granites, where the Sete Barras granite was probably contaminated by much evolved sources during its evolution. The Juquiá type magmatism is related to provision and melting of crustal materials deep enough to leave garnet-rich residues, and the Sete Barras type magmatism, whose melting was probably shallower, involving garnet-bearing sources generating a more evolved magmatic composition and garnet-poor residues. Well, uranium-lead geochronology and lutetium-hafnium analysis. Here the results of the uranium-lead analysis and catalysis images of the Juquiá granite. Red circles are the uranium-lead spots and green circles for hafnium analysis. Despite the dispersion of concordant age, the larger set of data provide a concordant age of 799 million years, interpreted as crystallization age, which agrees with previous ID team's data. The zircon crystals that provide this age are characterized by preserved oscillatory zoning, blurred primary zoning, and some patchy or striped zoning and homogeneous texture in the catoluminescence image. Well, choose different sets of zircons with older ages were separated from the main set. One with ages around 854 million years. The images of these zircon crystals that provide this age show a complex and non-unique texture. And another cluster with age around 833 million years. The crystals represent both inherited cores and xenocrysts or anticrysts. Well, for the Sete Barras granite, despite the dispersion of concordant ages, the larger set of data provide a concordant age of 602 million years, interpret as a crystallization age for this granite. The zircon crystals that provide this age are characterized by preserved oscillatory zoning, blurred primary zoning, and some patchy or striped zoning and homogeneous texture. Well, some crystals of older ages of 625 million years are separated from the main set and are interpreted as antichrists, and another cluster of age around 578 million years correspond to zircon crystals with metamorphic growth and resorption zoning. The monazite crystallization age of 598 million years is similar to the zircon age and may reflect the crystallization period of the granite, since there is no evidence of its metamorphic origin. Well, the negative epsilon half-nu values imply derivation from a source with clearly crystal affinities, and its range may suggest some modification of crystal melts. The igneous protoliths for both granites have some range in half-nu model ages mainly between 2.2 and 2.5 giga-years, which indicates that mantle rocks were added to the continental crust in Siderian and Riacean times. Well, there are several models of tectonic evolution of the Embu Terrane. Based on the available literature data and the ages and tectonic environments of the studied granites of the Embu Terrane, I'll show some paleogeographic reconstruction of West Gondwana assembly, always in the left side of the slide, and schematic northwest-south east sections from the southern Ribeira Belt, always to the right side of the slide. Well, at this time, an extensional phase occurring involving subsidence in the Paranapanema block, Toleitic magmatism at the Apiaí terrane, rifting and crustal attenuation, and Embu basin sedimentation interbedded with basic rocks. Crustal melting of Paleoproterozoic protolith with participation of metasedimentary rocks produced Juquiá type magmatism at around 800 million years. Mesoproterozoic Apiaí supercrustals, here in blue, may be covered by the Embu basin in brown in the middle of Tonian. The Paranapanema block Now hiding under Paraná Basin, the basementing layers of the Apiaí and the Mesoproterozoic rocks of the Apiaí terrane were possible some of the source areas of the Embu Basin sedimentation based on the Tritozircons population. Well, the subduction zone was active between the Paranapanema and Curitiba terranes, with magmatism being generated at around 680, 660 to 630 million years in the Embu terrane. At this time, the Apiaí and the Embu terranes were possibly juxtaposed by thrust faults. Orthogneiss here and amphibolytic rocks of the Rio Capivari complex and Curitiba terrane may be constitute a single microplate at this time. Here the supercrustal rocks of the Curitiba terrane. Well, synorogenic calc-alkaline magmatism represented by pink color here in the Ribeira Belt, both Embu and Apiaí terranes took place during the juxtaposition of the Curitiba terrane and Paranapanema block at around 630 to 605 million years. During the closure of the Adamaster Ocean also occurred the collision between the Curitiba and the Luiz Alves craton with calc-alkaline granites of PN magmatic arc generation, here in dark pink, and this juxtaposition of the Congo craton with all adjacent terranes with coastal terrane magmatic arc generation, here represented in dark red. Well, the Sete Barras granite, here in orange, may be associated with the collision setting related to the closure of this ocean preceding the extensional tectonics around 580 million years. The juxtaposition of Curitiba terrane and Luiz Alves terrane evolved with the subduction of Neoproterozoic oceanic crust towards northwest, here the PN ophiolitic sequence represented in green color. Well, the Rio Capivari complex today as basement in layers in the Embu terrane, represented by the gray color and white spots here, may be added at Embu terrane at this time by the Cubatão shear zone. The Cubatão shelter zone separates the Embu and Apiaí terranes to northwest from the Curitiba granite gneiss terrane to the southeast. Well, the sinistral Itariri shear zone dislocates part of the Congo craton, and the magmatic arc granites in red previously developed, creating a wedge configuration of the coastal terrane to the north of the Curitiba terrane. Well, here's some conclusions of this work. The Embu terrane is part of attenuated southeast border of the Paranapanema block. The basement rocks of the Embu terrane, the Rio Capivari complex, are interpreted as part of the Curitiba terrane juxtaposed to the Embu terrane during the final stages of the Gondwana amalgamation. In the Tonian period, crustal extension allows the deposition of the Embu basin and emplacement of the Juquiá type granites that represent a thermal event related to the final stages of the Rodinia breakup during expansion of one of the possible branches of Adamaster Ocean. The thrusting of Apiaí over Embu terrane occurred before the development of the main Ediacaran dextral shear zones in the Ribeira Belt. Pervasive magmatism took place in the Embu Terrane at around 600 million years, including the emplacement of Sete Barras granite, which occurred in a local transtensional area in the regional compressive environment. The final collisional phase in the Ribeira Belt, the juxtaposition of Embu, Apiaí, Curitiba, and coastal terrains, maybe occurred at around 578 million years, recorded by metamorphic growth in several zircon crystals, when the tectonic scape took place through major northeast-southwest shear zones. And finally, the coastal terrain is understood as part of the Congo Craton. Its basement rocks are similar to the Paleoproterozoic Kimasian supergroup of Congo, and its wedge configuration between the Embu and Curitiba terrains is due to the sinistral Itariri shear zone movement. Thank you very much for your attention.